started. First and foremost, I'd like to thank everybody for joining us tonight. Thank all of our panelists for participating in tonight's discussion and contributing their time and expertise and knowledge on the field of AI. And today we have the second part of our two-part series for the MIT Enterprise Forum that we've done in collaboration with the New York chapter, Atlanta, South Florida, and Israel, and a few other chapters helping promote it. So these are one of the first few events that we did globally for the global audience instead of just our local community. So I'm really excited about all the people that we were able to come together from all over the US to share their expertise and passion around a topic that's really important in our lives today and in the future, artificial intelligence. So a little bit about the MIT Enterprise Forum. It's a nonprofit volunteer organization that we come together in the intersection of business and technology and helping entrepreneurs and businesses leverage technology to make the world a better place. And we create these events to share knowledge between people that are passionate about things that they're working on in their lives and helping other people exceed in what they want to create in their lives as well too, either personally or business-wise. So with that said, I would love to introduce our moderator for the evening, Armando, and just let him introduce himself and the rest of the panelists. I'm really excited. Armando.
Thank you, Robert. I'm Armando Vitteri. I have been involved as a developer in AI since my college days. So back in the days of expert systems and Lisp and lots of parentheses. So I weathered the AI winter that lasted an awfully long time. And however, I came back to AI in the last 5 years as neural networks took off, as data science took off, as some of these old new techniques started to develop, and wound up founding a company that specializes in high-level AI consultancy and implementation. Dr. Nassim Ozer joins me on the panel. He's my partner in that company by the name of Technisoft. And we specialize in, again, engaging typically in large companies, doing AI consultancy, finding where the opportunities are, and then in turn, obviously doing the implementation side of things. So that leads me into an introduction for Dr. Nassim Ozer. Nassim holds a PhD in AI from Purdue. He has been active in the AI community from, again, the early days of the expert systems and Lisp programming and the like, but more recently wound up as part of this AI consultancy, has consulted with some of the largest companies in the world in architecting for the first time their AI strategy. And those companies have ranged from research and institutions in healthcare, such as Johns Hopkins, through multinationals in technology, including Hitachi, Toshiba, Western Digital, etc. Nassim, in that role, Nassim acts as both the company's chief technology officer, but also does a lot of the steering for the company and the kinds of AI technologies we opt to invest in. Also with me in the panel is Simon Lau. Always great to be on a panel with a fellow MITer. Simon holds a baccalaureate and a master's of engineering from MIT, but more intimidatingly, he graduated MIT with a perfect straight A when he graduated. From my perspective, where I barely graduated, in fact, I had to be talked to by the faculty more than once, I'm pretty damn intimidated. Simon is the VP of product at Otter.ai, which has developed an award-winning AI note-taking collaboration app for capturing meetings and conversations. Otter.ai is pioneering ambient voice intelligence technology to turn meetings, calls, and in-person conversations into easily searchable notes, summarize key points, and high-value insights. Also on the panel is Adam Rubenstein, who's CEO and co-founder of Track 365, which is a new kind of AI-based sales tool, which helps sales professionals master human narrative through the sales process. Track 365's artificial intelligence helps analyze your conversations to point out opportunities, risks, tasks, and other highlights, and guides users to do what's best for them and close more deals. Adam holds a MBA from the Wharton School. And finally, and very notably, Dr. Ron Weissman, who I've known for a number of years. I was a member of the Band of Angels, the US's oldest angel investment group, arguably the founding source of venture capital in America. Ron is a very active member in the angel investment community, serving on the board of directors for the Angel Capital Association. He's chairman of the software industry group at the Band of Angels, but he's also probably the person who has had more different careers in his lifetime as anybody I've ever met in my life. Because Dr. Weissman started out his career getting his bachelor, master's, and PhD from Berkeley in, of all things, European history and quantitative anthropology. You didn't even know there was such a thing as quantitative anthropology. Well, what Ron actually did for his PhD is he analyzed the use of social media during the Italian Renaissance. I bet you've never met somebody like that before. But through that career, starting out there, he's moved through a variety of roles, ranging from running the Supercomputer Center at Brown University, being a partner, the founding partner with Steve Jobs at Next Computer, being a portfolio manager and partner at Apex, one of the largest global private equity groups in the world. In other words, Ron has a very broad background. However, Ron also has the single most definitive presentation overview of the entire AI industry that certainly I've ever seen, and my guess is that exists in the AI industry. So we're going to spend our first half hour with Ron, having him do an overview for all of us about what he sees as the tricks and trends, the interesting features and functions, the investment opportunities, the fails and wins of the AI industry as it exists today. So with that, Ron, why don't I turn it over to you?
Armando, thank you for that very generous introduction. It is a pleasure to be here with such a distinguished panel, and I'm hoping for a really, really fun, lively discussion. Let me go ahead and share my screen. My overall view is we're between hope and hype, and hopefully this panel will help clarify exactly where we are between those two dimensions. So what you're going to learn today is all about crapware and zombies, why drinking coffee is hard, why a club sandwich matters, lawyers and killer robots, and to keep you basically up to speed at your next cocktail party, what's going to be 2021's leading AI buzzword. So stay tuned. We're going to talk a little bit about what deep learning is, what the hot sectors right now are. Are we entering AI winter? What's going to happen next? And then if you are considering joining or investing in an AI company, what are some of the questions you should be asking in 2021 that you probably wouldn't have asked a decade ago? So if we're in the 6th generation right now of AI, and the key takeaway here is that the two dominant paradigms of AI, rule-based computing expert systems, as Armando referred to them, and brain models, neural computing, have existed really since the birth of AI in the 50s. And it looked like expert systems were going to win. One of the most famous was a diagnostic system in 1972 called Myson. It was an attempt to generalize diagnostics in healthcare. But at the same time, the neural model languished. It got a real kickstart in 2006 when Professor Jeffrey Hinton, who is also Google's chief AI guy today, said, you know, we ought to be looking at neural models and feeding errors back into the system. And that insight created a real wave because his students won a image classification challenge, the most famous AI challenge called ImageNet in 2012, based on those insights in the late 2000s, and not by a little bit, by a very significant margin. And this kickstart a whole wave again of neural-based computing, deep learning. And where we are today is the applications of the work that's come out since, where we're using deep learning in everything from robotics to automotive technology to healthcare to marketing to commerce and to some of the verticals I'll be talking about. So that's where we are today, is the age of applied deep learning. Well, in the past few years, really kickstarted in 2012 after the ImageNet competition, we have invested $190 billion in AI funding and across 19,000 global AI startups. Now you can see on the previous slide, the amount of money keeps going up. And on this slide, the number of companies keeps going down. Why? Because more and more money is going into fewer and fewer companies. We're harvesting the results of mid and late stage companies. It's much harder to get funding as a startup than it is a mature company. So global trends, we've got AI is supplying many global markets well. As I said, $190 billion, nearly 20,000 companies. We've minted dozens of AI unicorns. And in 2020, the last year, 600 startups were funded, but with $44 billion. We've seen lots of mergers and acquisitions. We've done 110 billion so far, 635 companies simply between 2010 and 2019. About 6% of all active AI companies were acquired in that period. And half of all M&A, because there's a global arms race with the leading computer companies like Amazon, Facebook, and Apple, 50% of all M&A has happened in the past 3 years. Median exit around $60 million. There have been quite a few billion-dollar exits, pushing the average up to about 600 million. If you look at can you make money, the average exit revenue multiple, that is the price paid for the company compared to their revenues, is about 7x. And in terms of capital invested, investors are making between 7x and 12x the money they've invested for companies successfully exited. So while there's all this money flowing into the sector, there remain many unsolved core problems beyond what those original 19,000 companies are doing. New verticals we'll be talking about also create some large opportunities. So it's a maturing market in many ways, but there are plenty of new opportunities. Let's look at some of those hot sectors. These slides will be available to you. I will not going into to every point here. So what's machine learning? It's also known as a club sandwich because a deep learning model has many layers. One layer may look at texture, layer may look at color of an object, for example. One layer might try to recognize what that object is. So in the case of animal recognition, you might have layers looking at fur and tails and the presence or absence of feet and so forth, as determined as the model works itself. So you apply labels to millions of objects. Human beings typically apply those labels. You are training the model with lots and lots of data, and then you have some outputs based on the predictive capability of the model. But you have some errors as well. So you feed those errors back into the model until the model reaches a kind of equilibrium state. So that's the training part. And a trained model can classify things, it can tag, it can match, it can organize, it can predict, it can score, it rank, it can do many, many things. You then deploy that model against unseen new objects and make predictions, classify them, and that's really what deep learning is all about. The key thing here, it needs an enormous amount of labeled, normally human labeled data. Some examples of what AI can do. This is back from 2019. Deep fakes. These are all computed images existing in zero reality from NVIDIA, which is the leading graphics manufacturer and AI-based board today, using a technique called generative adversarial networks, where you look first at what's right about the image, and then you look at what's wrong about the image and recompute and recompute. These images took on average 18 days. That was the old world. Today, companies like Samsung are trying to create artificial humans in 2.5D. These, as part of the Neon project, will all be interacting with us in a 2.5 dimensional space, answering questions, solving problems, helping us from everything from booking travel to doing aircraft and automotive maintenance. And so stay tuned with Neon, Samsung's project. What's coming next is more what's called unsupervised learning. Supervised learning, we have to manually label things, and that's usually 90% of the cost and time in building AI models, sometimes $10 an item. If you're doing this across millions of items, you can see how the cost builds up. So we use that data to build and we validate our network. We classify new inputs based on that validated model. Well, supposing we could find ways of using less model data. We could discover common characteristics not by labeling data, but by clustering data, by using things like statistical analysis, a technique called k-means. So we can manage a much broader range of unanticipated supervision, unanticipated situations. If you haven't seen an object, how do you know what it is? Unsupervised learning, it can discover anomalies, unusual things, edge cases. In the case, for example, of cyber threats, Darktrace can find cyber threats that no one has classified previously. DataVisor does the same thing for financial breach. An Israeli company called Mindtrace can look at never before seen pedestrian obstacles and potential issues in crosswalks that is never seen before. So these are just some of the more interesting companies doing unsupervised learning, figuring out stuff without having to use labeled data. The next area that's going to explode is called XAI, which stands for explainable AI. Those models we showed before, those neuron-based models, are often hard to explain. They often can't explain how they came to the conclusions they came to. Well, the European Union, as well as several US states like New York, are demanding that any AI that touches a human being with a decision be explainable, be transparent, be provable. And this has now been legally mandated. And MIT is one of the universities taking a lead in looking at transparency by design. So why was I turned down for a loan? Why did that town that had no bad guys in it get shelved? Why was I turned down for insurance? Why was my ventilator turned off automatically by an AI, killing me? What happened? We need to go back, understand how decisions are made, and this is a brand new field called explainable AI. Now, speaking of trust, an interesting segue here. Who would Europeans rather be governed by? AI or politicians? Well, a study that came out 2 days ago suggested that Europeans trust AI, even with its lack of explainability, more than they do politicians. So I guess Europeans are getting smarter. Sense making. The buzzword here is situational awareness. What's happening around me? What's going on in my space? So when Maersk has a ship that gets in a report, it is using sensors and data from other ships in the area to figure out who is near me, what are they doing, what's their likely transport course. Similarly, the Canadian Air Force, with a company called LabForge, is looking at all of the risks in the air near my airplane. Taking this close to home, MIT is doing a great job of something called social value orientation by looking around, finding out what's happening in cars near me and what the risk might be. Are there kids fighting inside the car? Is the driver who's about to turn left distracted? And what might my car do? Maybe it slows down, maybe it waits at an intersection while there is a risk that's being resolved elsewhere around me. And Iris does the same thing inside my own car. So what's happening now? What are the risks? So sense making, trying to take sensors for sound, as well as vision, as well as motion, combining them to figure out what's really happening. Another use of sense-making computing is what's called affective computing, detecting emotions. So again, Affective is doing something similar to the last projects, looking at the emotional states inside the car for driver safety. iDetect is trying to use facial recognition and eye recognition to detect lies, and their early work has been admitted by the Arizona Court of Law as defensible. In the voice analysis has been used to diagnose PTSD with 89% accuracy at NYU. So these are some of the techniques being used to try to detect emotional states and turn emotional states into gold. We're seeing an explosion right now of vertical market technology. And we're moving, as I think, from tools to verticals. Why? Because we've had massive increases in the raw capability of AI. We have special processors like those from NVIDIA. We now have industry consortia, particularly in areas like insurance, to provide the big data we need to power our new solutions. Sensors for the real world are now incredibly cheap, and many machine learning frameworks are free. So some recent technical advances over the last year, we can now classify images with 90% accuracy. We can train those classifiers in 47 seconds, a 13x improvement over 16 months. The cost to train those classifiers has gone down from $1,100 per classifier to $7. We can detect deepfakes, like those images I showed you before, with 80% accuracy and a nearly fourfold improvement in just 3 months of research. We can recognize speakers with 99% accuracy, 130x improvement in 3 years. We can answer questions based on looking at visual evidence, looking at a movie and having an AI watch the movie and answer questions that's right now at the level almost of human performance. And that took 5 years, but we are 95% of what a human can do. Trying to classify what's happening in a video, we're less than half as accurate as a human right now, but we've made 150-fold improvement in a few years. Facial recognition, it is scary. We have less than 1% error now with facial recognition. We have human performance in normal question answering, and in speech to text, we have around a 2% error, 5-fold improvement in 4 years. So these are some of the advantages, the basic core technologies that are going to be powering the next generation of vertical markets. And let's look at what's happening in some of these markets like healthcare and real estate. So in healthcare, we're able to use AI to detect disease, to diagnose and classify disease, to do genomic screening. At the point now, the more advanced facilities can use AI in admissions triage to figure out what's happening with the patient and to do things like hospital bed allocation, as has been doing now for COVID cases. We can match patients with much greater accuracy for clinical trials. We can follow the performance of drugs once they've been released into the market, a technique called pharmacovigilance. AI is now regularly used. We can mine medical records going back years and years and years to find new or overlooked treatments. Uh, there's an arms race with the bill reviewers and the insurance companies and the providers, and all of this is being powered by AI. There are more than 100 blockchain systems allowing you to share patient medical records securely. We can do risk analysis of patients admitted to a hospital. Who is going to follow the protocol? Who is likely not to take their meds? And we can do the same thing to predict the outcome. How many patients will survive a clinical trial versus drop out? There's a very, very high rate of clinical trial failures simply because we picked the wrong patients who didn't last for the trial. On a population basis, we can do risk analysis using AI, and robotics are now using smarter systems for both surgical procedures as well as for post-op patient care. So here is just some of the results recently of comparing what AI can do versus what medical experts can do. We are better at diagnosing skin cancers. We are better at diagnosing depression. We've got 94% of accuracy in diagnosing over 50 eye conditions and so forth. I won't go over the whole list, but these are some of the areas: lung cancer, brain tumors, childhood diseases, lymph node cancers, Alzheimer's. We are as good or better than trained medical experts. Some of the cool companies involved in next-gen healthcare AI. One of my favorites is Cyclica in Canada, which can predict the toxicity and adverse reactions for drugs as well as cosmetics, simply by looking at the models themselves before they've actually ever been formulated. FDNA has been using facial analysis, facial recognition to look for genetic abnormalities. Babylon Health in the UK has over 1,000 staff building AI-based care plans that are as accurate as a physician's plan. And Medtronic has put into operation IBM Watson's Sugar IQ, allowing real people diabetic management downloadable from the App Store. So if you look where healthcare is going, and you everywhere from admission, triage, patient scanning, patient administration, AI is increasingly being used for initial diagnostics, being fed that data into the patient's EMR and exploring that EMR for other clues. We're using AI to transcribe those patient visits. We're using AI widely in image analysis and genomic screening. All of that is sort of supporting the next gen of diagnostic tools. We're using AI for coding and billing. We're using AI for clinical trials recruitment, for the development of treatment plans. What this all means is faster diagnosis, better outcomes, a better 360-degree view of the patient from pre-admission through post-discharge, higher completion rates for those trials, patient population, data mining, and so forth. What this will mean is improved lifespan as well as improved hospital margins. Lots going on with AI and COVID, everything from screening to disease understanding to data mining, where Northwestern is using text analytics across tens of thousands of research proposals and research findings to figure out paths that weren't taken but should be taken. So this is just some of the operations, improving hospital operations, but we need big data for this to be truly accurate. And we're only just beginning to collect enough data to make this truly statistically valid. Speaking of which, is health AI healthy? As a recent report from Kaiser Health Plan indicated, there is little research or proof that the 320,000 apps in the Apple and Google app stores actually improve outcomes. Most AI models that we build are tested in very sterile environments, not in real hospital settings. And very few AI companies actually submit their research to peer-reviewed journals. So as Gartner says, medical AI is at the peak of inflated expectations. As reality gets tested, it's going to be a rough slide into the trough of disillusionment. And one of my favorite quotes is, As we do in Silicon Valley, we like to fail fast and fix it later. That is not an accepted medical protocol. Real estate. What's going on in real estate actively now with dozens of companies matching buyers to properties, finding comparable houses to the one you've liked based on computer vision alone, identifying high value commercial properties and predicting rental income and cash flow, figuring out the best neighborhood to buy or the best house on the street to buy, using analytics to guide a buyer's bidding strategy, lots of tools to predict future property values, lots of tools to review contracts and to find anomalies and risks in those contracts. A number of companies in Scandinavia and Africa have already replaced our bizarre and antiquated title process with blockchain to really solidify and secure changes of title. So there's lots going on and dozens of chatbots allowing clients to interact with virtual realtors. One of my favorite examples happened in Denver, where 3 brokers were paired against 1 bot. And a buyer selected a house and said, I like this house. I'd like to see more houses like it. He didn't say what he liked about the house. The brokers then picked through the multiple listing service houses. They each packed 6 houses that they thought he might like. The bot did the same thing. And the bot beat the brokers in every case, guessing the house that the buyer was going to like best. Digital lawyers. We've got lots of lawyer bots, auto detection of conflicts of interest, machine learning using for e-discovery, for document redaction, for contract review, analytics for predicting case value and outcomes, and for profiling of judges and jurors, and lots of routine task automation, allowing paralegals to do higher level work. So the old rule was first kill all the lawyers. As Shakespeare said, the new one is replace them with bots. I bet some of you have heard of the Do Not Pay chatbot written by a 15-year-old in the UK that's overturned in its first year nearly $10 million in traffic fines, overturning nearly 400,000 tickets. Well, since then, this now 18-year-old has launched 1,000 new bots, all using natural language, for doing things like adjudicating maternity leave, landlord-tenant, and asylum claims. That the guy is now, I believe, entering his senior year at Stanford. Another test, AI versus lawyers. LawGeek's contract review software was paired against normal human lawyers. And the results were judged by Stanford and Duke and other law professors. Was the AI capable of detecting risks in non-disclosure agreements, and how did lawyers do? Well, the result was that the AI was accurately was able to detect 94% of NDA risks compared to 85% for lawyers. But the best part of this was that the AI took 26 seconds to review all 5 documents at that 94% level of accuracy, 1,000 times faster than the lawyer. The lawyer would have charged $3,800 in fees for reviewing those 5 documents. The AI would have charged $3.80. So in the enterprise, there's lots going on with enterprise use cases for things like reducing churn, lots of work in marketing automation, focusing on things like customer retention, improving the customer experience. So these are all very popular use cases. And to take a higher level view, here is a list of the most popular use cases across key markets in finance for things like bots for helping you personalize your financial planning, fraud detection, fraud detection, automation of customer operations, lots of work in optimization and transportation, lots of work in technology and media for things like custom content creation. As an example, visit the Salvador Dali Museum in Florida, where AI has created a 2.5-dimensional Salvador Dali that you can communicate with. He will take your photograph. He will answer questions using Salvador Dali's voice and a completely reconstructed 3D model of Salvador Dali using his normal motions, all of the peculiarities associated with a real person. It's quite stunning, and this is the future of digital avatar. Some radical use cases. In the current Libyan civil war, there was a case we discovered last year where one of the Libyan parties actually used robots with AI face recognition to track down and kill its enemies entirely autonomously against the current treaty for doing this, but the cat is now out of the bag. Lots of work in the rather unsavory field of sex bots, but this is much of the work involves trying to bring emotional intelligence to human interaction. So what's happening in the sex bot industry will enter the rest of the real world as it has in previous media. Digital actors, Hollywood's experimenting using entirely fictitious actors based on composites of real actors' voice and motion. Digital companions in healthcare. And one of my favorites is going on right now is the use of robotics and neural imaging and AI to find the exact zone in your neural structure where a bad memory is exciting your neurons, and then reprogramming you to erase those bad memories. This system, while scary, is already working. And finally, digital immortality, a la Salvador Dali, or their attempts to create entirely digital persona of your loved ones with whom you can continue to discourse. Some of these experiments, Zoolingua is using AI to figure out how to communicate with your pets. In China, you see 2 digital newscasters who look and sound fully human. We've had our first major digital auction of an artwork for $432,000 at Christie's. And my favorite to show that AI is real is the use of AI to develop the best pizza recipes and to automate pizza design. AI has had a long history of hype, and you can see some of the more outlandish claims that go way back. 1963, John McCarthy said we'll build a fully intelligent machine within a decade. The head of Google Brain said AI is the new electricity. It's more powerful than electricity itself. Same thing was said by Google's CEO. So we've seen there's a lot of outlandish speculation about what AI is going to be doing. Like in 1965, the machines will be capable of doing any work man can do. So beware the hype. In the UK, the House of Lords did a study on the reality of European AI, and they found that 40% of AI startups contain no AI. They found that there are only 300,000 AI scientists in the world, but 26 million software projects claiming to use AI. More recently, a US AI-based insurance company that claims to detect fraud using AI, using facial cues, actually had to admit that it's using no AI and obviously no XAI to look at potential cases of fraud. And they've been reprimanded for exaggerating AI claims, potentially to the detriment of real human beings. So we're back in the territory of old vendor snake oil. Be careful. We've seen lots of AI failures. The most spectacular was IBM's cancer initiative where they pulled out. But Facebook shut down a chatbot experiment when Facebook's engineers couldn't understand the private language created by the chatbots, and they were worried that there was that this was an uncontrollable experiment. Apple was sued for $1 billion for a false arrest because of a facial recognition error. And we've all heard the case of the 6-year-old who ordered a $170 dollhouse simply by asking Alexa for it. We've also seen Microsoft's chatbots was taught to swear, and she decided she loved Hitler. Here are a list of colors that AI image analysis and natural language processing thought would be the next big thing to describe these colors. Bunflow, bank butt, Carrington, Stargoon. So we've again seen that AI has led to some really spectacular and often humorous or embarrassing outcomes. So where are we in the AI hype machine? Where are we with AI winter and AI spring? So since the dawn of AI, new methods like neural computing have led to a whole new wave of hope. Compute power catches up. Investors then fuel new experiments, new companies. We get some pretty good applications, but it's never as good as what was claimed. And so people lose faith, they stop investing, and companies stop experimenting. We've had AI winter between 74 and 80, 87 and 93, and the early 2000s until John Hinton's experiments with backwards propagation, putting errors back into the system. So one of the questions that we've got is AI only for the top tech companies? We have a data science shortage. We have too few people who know how to build models. It costs a fortune to run compute servers, and it costs a fortune to label the costs. So what's going on with the vast computing resources needed to power AI? So what's next? A number of people think a new AI winter is coming, and a number of people are saying, what's beyond deep learning? What's the world post deep learning going to look like? So in my view, I want to focus on just a few trends. Right now, AI is experimental. It's more engineering than it is science. Some people call it digital alchemy because we can't explain it. We can't reproduce it. We can't trace it. We often can't validate the data we're using. We don't have data standards. We don't have quality assurance standards. And we have no theory of AI. How do we measure AI? How do we rank? And how do we correct AI? So where is the science in AI? This is, in the university world, this is becoming a hot topic. We need efficient AI. The number of calculations for breakthrough AI has grown 300,000-fold in 6 years. Between 05 and 11, we required twice the compute power every 2 years to have breakthrough AI. Now, compute resources needed to be at the breakthrough level is 3.4 months or 7x a year. Facebook's new natural language processing model, which is a small model, the training that model took 9 days and 3 times the annual energy consumption of the average American. So we need to overcome the limitations of deep learning, massive data, massive compute power, solving problems we've never seen before. We can solve what we've seen, but it's rarely able to solve what we haven't seen. We have no memory. We can't transfer our learnings from one AI to another. AI knows nothing about context. It knows nothing about cause and effect, and it lacks common sense. So those of you worried about general AI taking over the world, calm down. Without any common sense or cause and effect, that is a problem we haven't even begun to figure out how to solve. So the next generation of AI, Generation 7, is all about overcoming current limits. We need to go from scale to efficient AI, red AI, where we are today, to green AI. We're going to be marrying quantum computing, which allows us to go to billions of levels in a deep learning model that will radically transform AI. AI is transforming chip design. There are now lots of experiments and companies focusing not on big data, but what can we do with small data, with sparse matrices that don't require those millions of images or objects. We're bringing science to data science, lots of experiments to go from trial and error to scientific data discipline. And we're doing things like, as Armando knows well, automated methods for selecting the right model for the right problem. Ethical AI is one of the biggest fields that's being experimented with, particularly in universities, to eliminate bias, creating ethical data exchanges so the data you're getting, is trustable. This is the terms for these are things like AI governance and AI compliance. And brand new foundations, AI at the edge, where we can now embed AI into tiny processors. So what's happening locally is just as important as what's on your cell phone, is just as important, and collaborative AI is what's happening with big servers. Well, we're working, companies like the RAND Corporation and SRI are trying to figure out how to transfer memory persistently from one AI to another. We're looking at how do we use pattern recognition to figure out the why, not just the what. So the term to be familiar with going forward is neuro-symbolic AI, marrying rule-based symbolic AI with neural models. So you have your Babelfish translator on your cell phone communicating with big servers. It would be extremely helpful for that neural model to know that you're in a doctor's office versus a line in a supermarket. If it can bring context and rules, it'll do a much better job of being able to contextually understand what's going on. So to wrap up, 2021 isn't like the first wave recently of 2012. We have the outsized role of Facebook, Apple, Amazon. We have radical scaling of what's needed in terms of compute servers and data. AI platforms are now common, free, and everywhere, may mean more of us can compete. Greater awareness that AI has lots of hype. So we have smarter, more skeptical customers demanding more proof. When we win, though, AI becomes invisible. When it starts being used automatically in a bank for credit scoring, we forget that it's still AI. And our investors are moving later stage from earlier startups to more mature companies, raising the bar on financing. So if you are thinking of joining an AI company as an employer or as an investor, these are the questions to ask. Is the team world-class? Is it real AI, or is it simply reheated business intelligence? Can this AI beat the top kinds of benchmarks I've already mentioned? Do you have vertical market partners when you're building your vertical solution, or is this faith-based? My least favorite statement is, how did you build your product? Oh, my CTO came from Stanford and he's really smart. I want people with embedded vertical market knowledge. Are you solving a real problem or a science project? As the company an algorithm or a business? Are mainstream customers using this, or is it just the usual suspects, tech companies and government labs? Do you have a strategy for detecting bias? Where are you going to get your data? What's the plan for acquiring big data and for validating it? What's it going to cost to scale your company in the real world at the level of computation and data you're going to need to solve real world problems? And how many financing rounds will you need? By the way, don't investors and don't Apple and Google already have something like this? And finally, do you have customer validated, game-changing, best-in-class results? Because that's all that matters. Anyway, conclusions, we've got lots of companies out there, massive M&A, but getting to M&A takes at least 35 million in capital. The FANG are major competitors, not just startups. Guidance, look for markets not populated by Me Too's. Move beyond the hype, ask tough questions about AI quality and ethics, and focus on the ultimate question. Does this company deliver significantly better outcomes than other AI? Do the results make a practical difference? Thank you very much.
Well, thank you, Ron. Boy, there was a lot of information packed into that half hour. So thank you very much. Now, mind you, I have seen that presentation a few times. Every single time I've seen it, there's new insights that I get out of it. So really, thank you, Ron. So I'm going to come back to a few points that you made in there, and I'm going to turn it over to the panel. We've already talked about the fact that AI has gone through now a few nuclear winters. We're on the 7th generation of technology. There's been a long road of disappointment, disillusionment, billions of dollars that turned into nothing, as it turned out. What is it? So much has been made about that, the current hype cycle that we're in. How is today different? How is this cycle for AI different from all those other times that we've seen it? So, Adam, why don't you give us your view on this?
How is this cycle different? I think that the computing power and the results that we're seeing are there's a lot more power out there. There's a lot more solutions that are actually working well. And I think that the results speak for themselves, that it's, real AI. But of course, as Ron mentioned, there's a lot of companies that are using the AI terminology and they're not actually using real AI. So it's sometimes difficult to discern who is using and who is not.
Simon or Nassim, any comments to what Adam just said?
Yeah, just to add to that, it's the kind of like the tooling and infrastructure. So you can go to AWS and you can go to Microsoft Azure, and any startup would be able to have the foundation tooling to be able to train models. So I think it's having that tool set and having, in a sense, more data that has been collected over time, but also we continue to collect more data. And that it's really unlocking the ability for more people to innovate at this time.
I will look at it from the actual user perspective, and the difference between today and before, why it fails. Before, it was mainly restricted to academics, as you mentioned, the lists of the time and the expert system and etc. Today, it's actually AI is being used day to day. Everybody is familiar with the different translators that they can use if it's a Google Translate. Everybody know how to use speech recognition in many facets, in many industries. We actually, we remember the times that we had just the press one, they couldn't actually anticipate what we're actually saying. Now they actually can interpret what we are talking into the machine, and it's basically replacing a full operations. So the difference is now AI become at the hand of the actual users, as before it was just in academia, and it was just kind of different, smart people talking between themselves.
Let me challenge that a little bit. Ron made a reference to the catastrophic failure that IBM experienced with Watson at MD Anderson. And just so the audience knows about this, what happened is that MD Anderson decided to do a moonshot, do whatever it takes, using Watson, using AI techniques to come up with a system to diagnose cancer. They spent $62 million on it, and it was a total fail. So given that catastrophic failure, how do we avoid not having other situations, but in investing in AI for significant operational deployments? I open that to anyone that wants to take that one.
Well, I will follow with what Ron said. First, don't hype the expectations. I mean, one of the problems with IBM is they just claim to everybody that they are going to boil the ocean. And that really didn't work very well. So in order to avoid this, you have to actually look into different things. AI is very good when you're actually very specific on the tasks that you're actually supposed to solve, and not just try to solve everything in the healthcare industry, even in the cancer, that they actually focus on cancer, but there are so many types of cancer. There are so many causes for cancers. There are so many outcomes, the way that actually the cancer can evolve to. So that's one of the issues, is like they try to do too much, okay? And they try to sell it before even they actually succeed to produce it. And the last thing is about healthcare, which is very important, okay? I mean, we did some work on MRI scans of Alzheimer people that actually has the disease. And we tried to do this, we did scan brains, and you try to say, okay, let's try just look at the specific phenomena of this Alzheimer, okay? And you try to collect the data. Now, you have multiple sources to collect the data. I mean, there are tons of MRIs of many Alzheimer people, but now you have to identify what fits you. And now you have to see how you normalize it across many data sources. And what happened, actually, we found out is every MRI machine, okay, is being calibrated differently, Okay, take the image is completely different. The process, how they're actually taking the image, is varied between hospital to hospital. So even though if you can gather the data, okay, because it's not normalized, it's just pollute your result at the end of the day. So I think one of the issues for IBM, I mean, they use, I think, 4 sources of their own hospital to gather the data in their case. And then when they try to apply to the general purpose, it didn't really fit.
I was going to comment, there's a learning here. What I've experienced is that when you want to tackle something with AI, you need to be somewhat acute. You have to be very focused and define the problem. And people come to me all the time and they suggest how we could expand or broaden what we're working on. And all of it is theoretically possible, but the amount of data we need to get the results that will be meaningful is tremendous. And and it just is exponential. And so I think the biggest challenge is making sure you remain very focused in what you're trying to accomplish.
Moving on to a different topic. Ron in his presentation made various reference to the FANGs, these massive companies. I refer to them as I think FANG is a good one. I like to refer to them as the mafia. Microsoft, Apple, Facebook, IBM, and Alphabet, the mafia. The mafia represents 2 issues for younger companies in AI. Number one, they suck up all the available talent. If you're a freshly minted, brand new bachelor or PhD in AI, you're going to be offered a bunch of money and stock options to go work for one of those companies. How do smaller companies even recruit them? How do they compete to recruit that talent to be able to grow? The second issue that they represent is they put those people to work. And the amount of investment going on from the mafia into AI is enormous. It's enormous even relative to the venture capital investment going into young companies. So in that world, how does smaller, young, innovative companies compete? So we have 2 smaller, innovative companies here. So Simon, why did you take it first?
Well, that's a great question, and in fact, it's very relevant because right now, Otter is constantly trying to recruit talent in the Bay Area. It's very, very challenging. So one key thing that we'll have to continue to tell our candidates is that it is about company culture. It is about empowerment. It is about having a very lean and talented team so that everybody who can join a smaller company feel empowered beyond the box that we put people into, so that they can do more and achieve accomplishments faster. Case in point, I've shared a link of the Auto Live transcript of this session right now, and we have real results, and it's all accomplished with a team of less than 20 for a couple of years. We can get to this point. So in a startup environment, we can compete at the pace at which we innovate and the empowerment. So I think that has to count, and not everybody would appreciate that over monetary and salary motivations. I'll pass it to somebody else to answer this as well.
Nassim or Adam?
I think that, as you call them, the mafia is actually, I see them as beneficial. They're bringing people fresh out of the university. They're giving them 5 or 10 years of training. Eventually, these people get very qualified and get a great skill set, but they may get tired of working. They may get tired of being a cog in a very big machine. They're looking for something more creative, looking for something where they're more entrepreneurial, where they're going to do a broader set of challenges, and they're going to be part of something meaningful. As a company, to compete against them, we have to be more nimble, more creative, and I think that that's what the smaller companies like Otter and Track 365 bring to the table.
This has been the history of tech. After Fairchild Semiconductor back in the 50s, there were something like 60 to 80 spinouts because people had new ideas. They didn't want to work for a big company. They wanted to do their own thing. And there's no reason why this isn't going to happen as well within AI. Who wants to be stuck in Google for the next 40 years? On the compute side, I am seeing the majors, the major systems providers are now offering, free and reduced, not free, but reduced costs to AI startups to try to capture their long-term business. So one can run some pretty sophisticated stuff, using Azure and IBM and other, and other massive, compute for higher systems.
I will say that, I mean, I agree with everything that was said here, but in addition, in part of the thing that we found a way to actually compensate for what's going here in the Bay Area and etc., is we open offices in multiple places in the world, okay, in Europe, in the Far East, and etc. And based on this, we just try to cultivate the best of the best in every place. Okay, so at the end of the day, if, the really promising one are being sucked to the big guys, okay, you still are able to get very good talent and don't compromise on a mediocre or less than mediocre talent.
Let's transition over to the questions about ethics, ethical AI. So why don't I lead off with a question that was posted from the audience from Shalem Goldstein. Even if not in the next few years, do you think that at some point AI will be advanced enough to have actual feelings and wants? Will AI demand rights, etc.? Ron had volunteered to answer this question live.
Just one thought here. I mentioned sex bots. Well, this is what's spurring the development of truly of AI, which is able to at least have a verisimilitude of human interaction. It's seemingly like human. And that's the kind of use case that's going to actually help us build more into the general market, as well as healthcare is doing the same thing to try to create chatbots and robots with empathy that seem to understand human emotional cues. And you have to ask yourself the question at some point, what is good enough? If it looks and feels and talks like a duck, is it a duck? A Turing test for emotions. So my guess is at some point, faster rather than slower, we're going to be seeing emotionally responsive AI that behaves much the way we would. But when it does it wrong, we'll be in the uncanny valley, and it will probably be so wrong it'll be outrageously weird. But I think this day is coming pretty fast.
Hey, Ron,
anyone else want to take this one?
Just kind of a joke. I mean, it's combine it with the killer bots that you mentioned, then the sex bots can be a kind of fantastic assassin that you can create.
Wait, hold on. Isn't that called marriage? Sorry. I was just there. Anyone else want to make any comments on this question?
Well, even right now with therapy pets, it's happening now. I've seen AI bots that are being a companion to people, and not only just for regular folks who want pets, but also from therapy pet standpoint. So I think at some point, real pets, real animals have rights, and yeah, I see it's imminent that there will be feelings in AI bots, and also talk about demanding rights, or we advocate rights for AI bots. Yeah,
now we just have to find a politician that will run on it.
So now, much has been made about AI and machine learning lacking ethics in decision-making systems. How do we avoid this? Anyone that would like to take that one?
I think at the end of the day, it's like depend on the creators. I mean, it's at the end of the day, that's what I mean. It's like you ask an ethical nuclear bomb or an ethical, I mean, it's like the end is how you use the technology. And it is at the hand of the user.
We as humans, a lot of us learn our ethics through religion. You know, I'm curious, well, whether we'll have to kind of layer the AI engines with training in ethics and religion to provide them so they can kind of self-guide and, you know, make their own decisions.
Okay, I'm going to move on to a question that came from the audience, which is an interesting one. Is there really a global market for AI, or is the China market really fenced off by the Great Firewall?
I think you have to separate commercial from defense and intelligence applications. In the commercial market, China is very willing to both to have its companies sell into global markets, companies like Baidu, and they're certainly willing to acquire any technology that that's available on the global market, which is why the U.S. government has a program called CFIUS to monitor the export of critical technology, including AI, that could be used for military purposes. In terms of what China is doing militarily, well, like every other government, they're going to keep that to themselves. But in terms of commercial civilian applications, there really is a global market, at least right now.
So Ron talked about explainable AI. What are the ramifications of not implementing explainable AI, and what are the prospective legislative frameworks around that topic?
Have any of the panelists had to deal with XAI, explainable AI? If so, Jeff.
We work on the technical perspective, but not from a legal perspective or anything like this.
Ron, do you want to take that one on the legislative side?
So in 2018, the EU said that by 2019, any AI impacting a human decision, like the denial of insurance or medical diagnostic, had to be explainable. Well, guess what? There have been lots of waivers because it's super, super, super hard. So people have been passing legislation in the abstract. I don't know if there have been any actual court cases where somebody's been taken to court or to a regulatory body for failing to do this. But my guess is that day is soon coming. There was a case, a couple of cases in California, one in Canada, one in California. In the Canadian case, a judge disallowed legal expenses of a certain sort to a law firm in a litigation, saying, you should have used AI technology to automate most of that. Why are you charging us for man hours? I know that stuff exists. You should have used it. And in California, there's at least been some talk at the California Supreme Court level about what are the legal responsibilities of lawyers to become technologically conversant and to understand the risks and benefits for the purpose of figuring out things like liability. I think one of the hot areas for the law, for lawyers, is going to be AI liability going forward. If you're using bad data, if you're using unvalidated data, if you're using untested models on real people, those are, I think this is going to be a class action lawsuit field day in the area of product liability, and something that we as investors and as technologists need to be aware of as well, what our risks are, particularly for product liability.
So related to ethics, I'm going to take another one from the audience, from Michael Hansen. How will AI impact the future of human work? What types of work currently performed by humans cannot be displaced by AI? Adam, in fact, you are doing a package that is displacing or at least increasing sales productivity. So that one might be a good one for you.
Sure, I get questioned all the time whether AI is going to just replace salespeople. And I think that at the very basic, we see chatbots and things on websites where they're doing the most basic response to potential customers to help move them along the sales process. But I think that in time, it'll get further, deeper into the sale, but ultimately, sales is mostly about emotion, rapport, trust. And I don't know if people are going to trust AI or a chatbot or something that's inhuman in the near term, maybe in 10 years, and it may be some section of sales, because sales is a spectrum. There's very simplistic sales and there's very complex sales. So it's somewhere on the spectrum of, the gas station attendant, or I'm going in to buy shoes at the shoe store, and there's a limited amount of, knowledge needed to close that deal.
Anyone else want to take that one?
I can jump in here. Yeah, I'll add to what Adam is saying as well. I think the near-term practical applications of AI, to some of the examples that Ron also mentioned, I think it was the lawyer bot example, right? Being able to process lots and lots of information in a superb amount of ridiculously short amount of time. And that's something that's very, very powerful, both in legal, but also in contact center industry, where you have lots and lots of calls and emails and inbound inquiries to process. So I think that's where AI bots can be superior to human and be able to shift some of the more complex customer interactions, whether it's customer support or sales, and the higher value, more complex interactions to still be performed by real human agents and real human people. And so I think it's still going to be a few years down the line before some of the more complex tasks and those that require building a rapport with your customer and having that human touch, human interaction. I think that's further out, but for now, I think it's shifting and empowering people to do more and focus on the higher value complex interactions in the near term.
One of the interesting hot topics right now is not replacing humans at all, but having AI solutions that wed the power of a human expert and an AI system together, particularly in areas like healthcare, where they're finding the accuracy rates of adding a human and an AI can exceed 6 nines. So I think that we're going to be seeing the continued use of humans in mission critical applications.
I mean, just to add to this, but I mean, there will be segments that people will be displaced. Okay, I mean, as Adam mentions, I mean, the sales is based on emotion, but all the sales assistants and the sales secretaries and etc., those might be displaced. Okay, the same thing on the paralegal side start to be, all the preparation work and etc. Those guys can be displaced. I mean, we can see it also on the accounting and filing the IRS. I mean, everybody that goes to a CPA probably now see that the CPA is sitting in front of the software that connected directly, to a server and then submitted to the IRS, and it basically doesn't have much knowledge. It just, okay, I cannot put this amount because it's already telling me that I'm not allowed to because I put too much here and etc. So it's removed their basically expertise and consideration and gave it to the actual software. I don't know if it's AI at this stage, but it just can be just a rule-based system in this stage. But we are seeing down the road that right now we are going to record all the bank transaction is going. I mean, this is the new rule that they are trying to apply, that every transaction that everybody do through the bank, okay, going to be recorded. So complete all this huge data and have your tax report at the end, and maybe it will be completed by itself. We just have to sign at the end, or maybe even this now.
Shifting on to a different set of questions. Ron pointed out already that there are a lot of AI companies out there that have no AI under the covers. So since AI seems to be the buzzword of the hour, how can you tell if there's actually any real underlying breakthrough AI technology driving a software solution? I'm going to pass that one over to Simon, because what Otter.ai seems to be doing is pretty remarkable. And I am going to look at the transcript. How can you tell that there's any real stuff there?
Noodling on an answer and wondering if we can interpret the question from two perspectives. So whether that question is being posed on a job seeker, right? A job seeker potentially joining a company, or a customer who's evaluating a solution, right? So I would say for the first part, a job seeker evaluating a company, you have to do your homework, do your research, and see who else is in the company, and check out the LinkedIn profile and see what they do in the past, right? And just research the people who are in the company. And part of the interview process, talk to the people and see if they have legitimate skills, right? And then you know whether it is true AI or not. From a potential customer evaluating a solution, look at the results of whatever product and services that you're looking for, and analyze and compare against other competitors and see if it's really providing leaps and bounds 10x improvement for whatever the measurable metrics that you're seeking. Oftentimes, legit AI companies, if they play the cards right and really apply it to what they're selling, they should be able to achieve those type of leaps and bounds 10x results. Because ultimately it's not sustainable. Take the example of live captioning. Right now you're looking at the live transcription. Well, can a human do it? Possibly. I mean, there are live captioners trained to do it, but oftentimes you see segments where portions of what people are saying are not transcribed, and there are gaps, and there are things that it's just not humanly possible, or very few people with that skill set are able to do. So I think the results would be able to provide some hints and evidence whether it's legit AI or not.
Well, I've seen the SIEM be brought in by various angel groups to answer exactly this question, because the slideware looks great, and the SIEM is then asked to actually do the deep dive into technology to figure out if there's any there. My experience also with the SIEM and having looked at those, it's a pretty big majority of them do not have anything under the covers, right? So Nassim, how do you do it?
I mean, there are a lot of people that say that they are doing AI, and then you find that a lot of small companies, and then you find out that they just do a combinations of using services from Amazon, so using services from Google and some other companies, try to package them together and said, okay, this is our new product. So basically they don't have any IP or anything innovative. They're just using other services and try to package it in a different way. And the thing is like, usually I just drill down and try to find what is the differentiation, what is the real IP that they are claiming to have, okay? And in what way it's really different from what's going on right now in the market, okay? And even if it's kind of a smarter algorithm for explain about AI, I mean, that's one of the one that actually I had to dive to, okay? And it was very promising. It has to actually show, all the differentiation from a mathematical perspective and from a concept perspective than the regular one. So there is no other way if you want to find if somebody is a breakthrough, if not just to dive in and really see if it's different or not. And some of the company, I mean, the last one, I think, if you know, they were really not forthcoming. They will not mention a name, but they, try to say, oh, we have this fantastic, amazing database that can think by itself, but they're using tons of buzzwords, but nothing to show off. And when you start to ask questions, they just give you more buzzwords. So
Armando, let me ask a question of my colleagues here as well as the audience. Given what we now know about AI and what AI is doing, where it's going, what advice would you give a student graduating from MIT about career paths and what they ought to be doing next? Is AI changing any of this? And you know, what is your advice to your younger colleagues?
Anyone want to take that one? Well, I have a son that just graduated MIT with an AI degree. My only advice to him is that he wasn't sure what he wanted to do, so he's off getting his PhD now. So I guess the advice was stay in school. So anyone want to take that question?
Yeah, I mean, I will look at it from a different perspective. I mean, one of the things that we are missing here, we are talking all the time about the AI side. And AI is, I mean, it's a lot, it's not just a syntax, you know, of, TensorFlow or Keras or something like this. It's not just learning the syntax. It's like, it's deep learning of, data analysis, statistics, and math, and etc. So in order for you to really be, good at what you do, you have to understand it. One of the things that I would suggest for people to do is basically to mix, to create a hybrid. If it is a new student, the thing that we are missing when we are doing just the AI and we said we can treat everything the same, every data that comes exactly the same, is different if you actually have a domain knowledge. If you are an expert in nuclear physics and I'm trying to create an AI model for you, it will definitely lack, okay, unless you actually go and learn by yourself how to do the additional AI and the data analysis in order to complete your work. And so at the end of the day, there was nothing kind of, change with regard to, you have to be good in some domain or know some domain, have a real domain knowledge. And then from this, you progress and build on top of it all the tools that the AI can provide you.
I think that makes a lot of sense. Everyone, it's a problem-solving challenge where you need that expertise. You need to be, if you want to do a project, you're asked to do AI for engineering, you probably need to have some amount of mechanical, electrical, engineering background, or physics, or biology if you want to go into medicine or medical field. And so the advice would probably be somehow on their own, they have to figure out where they want to focus their AI, because it's like being a doctor. AI's got a lot of branches. Are they going to be a neurosurgeon? Are they going to be a heart surgeon? So from an AI perspective, do they want to get into natural language processing, or do they want to go into image analysis, or just structured data? Once they figure that out, then they can try to find a role that will allow them to, coach them up. And then, 5-10 years of experience. And I don't want to dissuade someone. They don't need 10 years, but 5 years of working under somebody, being mentored and learning how to solve these problems, then they can go out on their own and do some really creative work, cutting edge work.
Yeah. I can add one more relevant thought on that, since I graduate from AI, and hopefully others can relate as well. What I gained from the MIT education is the ability to learn, whether it's AI or whatever comes after AI. So being able to take in the information, like Nassim is saying, know the industry, find your passion, whatever problem that you're trying to solve in the respective industry that you want to immerse yourself into, have that passion to learn what's relevant right now, what can be applied to address the problem that you're passionate about. Go deep, learn a ton about it, connect the dots, and have that peripheral vision to be able to watch out for the next disruptive technology and be adaptive and always continue to learn. I think that's a very important lesson. And connect with people, all the experts who know and can help you go even deeper, or even go broad to understand how AI or whatever technology that comes after that that can apply to the industry that you're passionate about.
So we're down to the last few minutes. So I'm going to do one last question. And this one comes from the audience, Gordon Belcher. It's a little bit of Isaac Asimov's laws of robotics, but here goes the question. Could AI bots possibly become independent entities, i.e. not under control of their creators, able to act against the interests of their creators or owners? Who wants to take that one? It's a good one to end on.
On the one hand, of course, at some point in the future, but that involves artificial general intelligence. It involves intention and will, understanding cause and effect, understanding context, and we are nowhere right now, nowhere in those domains. So can we solve those problems in the next 10, 15, 20 years? Quite possibly. But is this something that that one should worry about right now? Probably not.
Or to be provocative, maybe it's already happening right now. Have you been listening to all the UFOs lately? Right? Just half joking.
However, if we are living in the Matrix, right? If we are living in the Matrix, then of course it's already happened.
Aren't there the 3 rules of robotics that we have to embed in all of our technology?
Sure, why not? You might as well start now. Anyone else want to do that one? Answer that question.
Technically speaking, it can actually happen even today unintentionally. So think about it. We were working with a company that developed a kind of an Alexa type, but specifically for the elders, to remind them when they have to take, their pills, what they have to do, what their calendar, when they need to sleep, when to turn the lights, when to have a specific type of lights that they need to absorb and things like this. So I can imagine, situation. Usually the more older we get, the more stubborn we get. So you can own the machine and you don't want to do stuff, but it will force you to do the stuff because that's what it's supposed to do. So, it's like kind of this way to try to find, but it can happen situation that, it does think that we don't want them to do the machines, even though we own them at this point.
So I guess a final comment from me before I turn it back over to Robert for the close. I have been involved in God only knows how many sit-down sessions with especially larger companies, but also younger companies or smaller companies, where we've done an analysis of where the AI opportunities existed inside of that company. And regardless of field, regardless of domain, regardless of anything, you could almost immediately in a couple of hour session come up with half a dozen, maybe more opportunities to apply AI in a way that would be, at a minimum, have a strong ROI, and at a maximum would be transformative for that business. So there is a greenfield opportunity here, I think largely limited by the in-house ability to go gain that talent or to resource that talent to be able to apply some of these techniques inside of these companies. So it is a fantastically large opportunity and something that will transform every single industry that you can possibly name. And I do believe that it is here to stay. And I don't believe that this is another nuclear AI winter that we're going to get into. Instead, it's just the beginning of a deployment, again, that's transformative across a broad range, across all industries. With that comment, let me turn it back over to Robert for the close.
So thank you everybody for participating. It was a really lovely conversation. Just thinking about all AI and the direction that it's going and it's constantly evolving. and just seeing what everybody's working on and the perspective that everybody brings is just refreshing to see what's the next generation of AI is going to be. And with that said, wanted to thank everybody that came out, participated tonight, but not just tonight, over the last year, and additionally over the past 30 to 40 years that the MIT Enterprise Forum has been around. With that said, the MIT Enterprise Forum has decided globally that they're going to close down after the close of this fiscal year, which is at the end of June. So this is our final event of the MIT Enterprise Forum of South Florida. But to continue on with the legacy of that we've been building over the last 30 plus years, we're going to continue to host local events and roll everything into a new nonprofit organization called the Explore Foundation, where we explore different technologies and explore entrepreneurship and help each other connect together in order to build things for the future. So stay tuned for that. We'll be sending out more information. We have just a regular brief landing page for everybody to kind of transition into, but we will be transitioning over the summer into the new foundation to continue on the legacy of bringing together technology and business and creating a better world together. So just want to thank everybody, all of our panelists, our moderators, and all of our participants for taking the time and energy to just be with us tonight and just talk about this topic that's passionate and it's changing all of our lives, not just in the future, but today as well too. So thank you again, and hope everybody has a great evening.